Okay, so matrix multiplication is different than addition subtraction. Addition subtraction was they had to be exactly the same dimensions to be able to add or subtract, correct? Well, with matrix multiplication, the columns of the first have to equal the rows of the second. So these two, the columns of the first have to equal the rows of the second. It is a have to, and I will go through the procedure of multiplication, but this is how you know if you can do it or not. So when I multiply these two matrices together, my product is a 3 by 4 when I'm done. So I have a 3 by 2 and a 2 by 4, and when I multiply it together, I get a 3 by 4. Can somebody give me a matrix that I could multiply by the 3 by 2? Give me another one.
2 by 6.
A 2 by 6. So if I had 3 by 2 and a 2 by 6, what would my product be?
3 by 6.
3 by 6. So when I do these problems, I write 3 by 2, and I do this. I circle them every time, and I put an equal, and my answer is there. If they don't equal a 3 by 2, actually, I'm going to reciprocate these and see if it's commutative. How about that? I have a 3 by 2, and this would be I want to do that different. Sorry. I'm going to do 2 by 4. I'm going to see if it's commutative. Times a 3 by 2. So I would circle these two. Are they equal or not equal?
No, not equal.
So they're not equal and is undefined. So is matrix multiplication commutative? No. If it happens to be, then it's an identity matrix, and we'll deal with that later. We still haven't gone over anything yet, how to do it, but I want to talk about what was the zero matrix? What was it? What did it have?
0.
1 0?
All zeros.
All zeros. So it's all zeros. So what do you think a square matrix is?
All square roots.
No. Close.
All squares.
No. Has to do with its dimensions.
Square.
It's square. So a square matrix, the rows equal the columns. So R is rows, C is columns, right? So a 2 by 2. Or a what?
4 by 4.
4 by 4. Or a 28 by what?
28.
28. That is a square matrix. A row matrix.
All rows.
Just one row. It's just one row. It can have any number of columns, but it just has what rows? One row. So then a column matrix,
One column.
one column. So can something be a column matrix and a row matrix?
Yes.
How many things would be in the whole thing? One. So if it was both column and row, so let's say like -6. How many columns does that have? One. How many rows does it have? One. So, but the only way it can be both a row and a column matrix is if it only has one element, correct? So that's it. Still haven't done any multiplication. Guess we better do that, huh? So matrix A is negative 2, 1, 1, 0. Matrix B, oh, they were nice. They gave you 2 by 2s. Negative 1, negative 5, 0, 4. I would highly suggest writing the matrices on your paper before you multiply them because of the fact that when you multiply them, you have to keep going back and looking. So if you were going back to your page in your book, odds are you don't get back to the same problem, right? So I'm going to do, and what they would do is they would do A, B. What's that mean to do? Times, multiplying. So a lot of times they'll give you like 4 matrices and then say add them, subtract them, multiply them. They just ask you to do a whole bunch of stuff with a bunch of matrices. Okay? So it's going to take negative 2, 1, 1, 0. And negative 1, negative 5, 0, 4. I highly suggest you don't squish these in so you see they are individual numbers. I like to write the dimensions on the bottom. So A is a what by what? 2 by 2. B is a 2 by 2. So these equal each other. So my answer is going to be a 2 by 2. That is good to know. Because if you get off on the pattern and you end up with a 3 by 2, you did something wrong. Okay? So this is an operation. You do rows times columns. And I should have started in different colors, but I think we'll be okay. So you take your first row. It gets multiplied times your first column. So the first row is negative 2, 1, negative 1, 0 is our first column. So you take the first thing in the first row times the first thing in the first column. Plus the second thing in the first row times the second thing in the first column. I know. Okay, so now we still have to do, it's like, think of it like distributing. I have to multiply everything by everything else. Make sense? The 1 is right here. We're doing first row times first column. Yep. Okay, so now I need to do the first row times the what? Second column. I need to distribute it. I need to share it everything. So this is one term. That sum is going to be one term. My next term, moving over, is going to be the first thing in the first column times the first thing in the first row times the first thing in the first column. A second column. Oh my gosh, I need to start talking and writing at the same time. So then I have to take 1 plus 1 times 4. So we finished the first row, correct? Now we got to go to the what? Second row. So that element's going to come right here. So second row, first column. So 1 times negative 1 plus 0 times 0. Then we have to take the first row times the second column. So 1 times negative 5, 0 times 4, plus 0 times 4. I always forget to say the plus. Now I want to look at this before we go any further. Do you see the columns in the columns? Do you see how those match up? Negative 1, 0, negative 5, 4. If that doesn't match up, you did something wrong. Do you see your rows? Negative 2, 1. 1, 0. Do you see that pattern? Okay. Now, the reason why you have to have the columns of the first to the rows of the second is because I would just keep going with this process. So if I had another column, I would just do the first row times that next column. I just keep repeating the process. So this is negative 2 times negative 1 is,
-2 or 2.
so 2
Plus 1.
plus 0,
Oh, yeah.
10 plus 4,
-1.
-1 plus 0, and -5 plus 0. So my answer is 2, 14, -1, -5. So I said in general, matrix multiplication is not commutative, is it?
No.
If it is commutative, it's called the identity, and you end up with the identity matrix that we'll see in a little bit. But let's see if AB equals BA. So I have to physically, I would rewrite them because it's very hard to do this backwards. So I have -1, -5, 0, 4. Times -2, 1, 1, 0. Make sure you've written the right numbers before you start multiplying, because if you don't, are you going to get the right answer? No. You guys want to try this one on your own?
Yeah.
Okay.
Will it always be a plus in the middle?
Yeah, it will, like this -5 would make it a negative, but you always put plus. Does that make sense? So if you want to just put a minus because it's going to be, that's fine. Like I just did here.
How did you get? Oh, never mind. I was doing it the wrong way. The second one, how did you get -5?
This is right here.
I thought it was always gonna be a plus.
Well, it would be plus a negative, like this, and I don't like doing that. You can put plus a negative if you like. I personally don't like to do that. It gives me the cringes.
I would have still put that plus sign since screw the negative sign on it.
Yeah, the negative has to be there.
Actually, I think I would have did plus and then negative.
That's fine.
Just like I cannot get these right. I'm getting myself very confused.
Okay,
Yeah, I'm confused.
so row times column. So -1 times -2. -1 times -2. Plus
Just send me off.
-5 times 1.
Wait. Okay.
Row
Row.
times column.
Wait, you know the next one.
0.
So then you have to do the first row times the second column. So -1 times 1. -5 times 0.
It'd be helpful if there wasn't lots of ones.
Well, I wrote the problem down so we don't even get the same answer the book does, but that's okay.
And then 5.
So we'd be checking our answer going, I did get the right answer. Because this one is supposed to be negative.
Wait, now
That's
I
someone
need
get
to
it?
do the
Let's
bottom row.
go. I don't get it.
Second row times the first column.
Well,
Zero.
Do anything with the second column?
Yeah. First row, first column, first row, second column. Right
You
here.
gotta do the second row.
And then you have to do the second row with the first column, the second row with the second column.
So first row, first column, second row, second column.
Oh.
First row, first column, first row, second column, second row, first column, second row, second column.
I get how they add up now.
Okay.
I get it.
Okay, so you guys still have your matrices written on your paper, yes?
Yeah.
Okay, so now we're going to do a problem. A times A plus B. Well, what does that tell me to do?
Too much. Plus A plus B and then times that answer by A.
Right, it's A plus B times A. Now, we know addition is commutative, yes? Cadence? No, no.
I'm changing my contact names.
No, no.
You would have sent me to the office.
Okay. Now, in this case, I add once and multiply once, correct?
Yeah.
I'm going to ask you a question. Could I do this and get the same answer?
Yeah.
Yeah. Because I'm only multiplying one time, right? Like I'm not switching. But on this one, I would have to add once and multiply what? Twice. Other thing is, you notice where this A is at? It's on the left, right? Where'd I keep it? On the left. If it was on the right, guess where you would have to keep it? On the right, because matrix multiplication is what? Not commutative. Does that make sense what I'm saying? This problem here and this problem here are not the same answer. Because this would still be A times A, correct? But the next one would be what? BA. And did we already show ourselves that AB and BA were not the same?
Yeah.
Yes. So we have things we call left-hand products and right-hand products. If it's on the left, it needs to stay where? On the left. If it's on the right, it needs to stay on the right. Now, I'm assuming you guys want to add and then multiply, correct?
Yeah.
Yes? Okay, so try that. You got your matrices. Add first and then multiply. Element to element. Oh, and can we multiply it? Well, a 2 by 2 plus a 2 by 2 is a 2 by 2. So I can still multiply it. You're right. Okay. Always check whether you can multiply.
How'd you get like -4 and -4?
Because we're doing A plus B first.
I know, but like
So
I
A-
don't even have -4 in my matrix.
Okay, but A plus B. So -2 and -1 is -3. 1 minus 5 is -4. 1 plus 0 is 1. And 0 plus 4 is 4. You have to add first.
That's confusing.
For today, I would highly suggest you write these out. Now, tomorrow, if you want to skip and do some in your head or whatever, you're more than welcome to. Like sometimes I just write the product. So I just write 6 plus 1.
I hope this is our last example because it's probably gonna take forever.
We've barely even started.
Well, yesterday we went through numbers fast. So.
Addition and subtraction is fairly easy, though. There's not. Only thing there is they have to be the same size, right?
I don't know how you don't get bored teaching math all day.
Because I love to hear. I'm confused. How'd that work out for you guys?
Great, I
Dookie.
spelled it correctly.
We have one, actually, we only have one more example.
That's a lot.
It's the identity matrix.
Cutting it. Willing to learn how to be in life.
Honestly, now you do. You're gonna count your crowd like this.
Okay, now I'm going to tell you what the identity matrix is, guys. Put your chair down. But you still have to do the math, just so you know. You can't just write the answer because I've told you what it is. Is everyone ready? Okay. Okay. So when I have like a multiplicative identity, it's the number I multiply something by that doesn't change it at all, right? Correct? So the identity matrix is a matrix I can multiply by a matrix and get itself. I will share a few with you that are used a lot because they're nice. A 2 by 2 identity matrix is 1, 0, 0, 1. Now, if you think about this, when we do matrix multiplication, we're multiplying and adding, correct? So we would be multiplying by 1 and by 0 and then adding it together. So would the number change at all? No, because 1 would be 0 and 1 would be itself, right? So a 3 by 3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1.
Where have we done this before, Miss May?
Where have you done this before,
I
guys?
hate that.
Gauss-Jordan elimination, correct?
What's
what?
that?
When we did Gauss-Jordan elimination with the row operations, you'll do it again next year.
Oh, no.
And we got this on the left-hand side every time we were done, didn't we? We were making the identity matrix. So what do you think a 4 by 4 looks like?
Same thing.
1 0 0 0 1 0 0 0 0 1 0 0 0 0 1.
She lost me all the zeros, but I think she was right. So what do you notice about it?
The one just keep going in a diagonal.
Okay, one's on, it's called the main diagonal.
Connect 4, you win.
Yep. It's the main diagonal, and what's everywhere else?
0.
Zeros. Okay? So that is the identity matrix. So we are going to do a 3 by 3 multiplication, and we're going to do that and that. But I will tell you, identity matrix, we have like, how do I want to say? It's called or shown or written I. Okay? Oops. I. Another fun fact fun fact, is IA will equal, guess what?
To owl.
AI. So that's the left hand and the right hand product. So if the matrix multiplication is commutative, bless you, you are multiplying by the identity. Make sense? So it's the one thing you'll be commutative. Okay, so we are going to multiply AI. If you want, we can do IA, but we're going to do AI. A is 1, -3, 2, -4, 5, -6, 9, -7, and 8.
I'm not gonna lie, I thought we were using those zeros and ones.
We are. That's what I is. Okay? So I said I of this, well, this is a 3 by 3, correct?
The 3.
So it's going to be this.
1,
So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now, do we need to write it all out, or can we just write the product? Just write the product? Okay, so we're going to go first row times the first column. Just because there's more things does not matter. We have a 3 by 3 times a 3 by 3. So when I'm done, I'm going to have a what? 3 by 3, and it better be exactly what I started with, correct?
What you started with?
Yep.
I thought you were
'Cause-
making it.
Nope. We're not making the identity. This is the identity.
AI.
Okay, we're not making it. This is the identity of every single 3 by 3 matrix. Okay,
Oh, I know.
So-
Okay.
Carly, put your head up. Okay, so 1 times 1 is
1,
1, plus -3 times 0 is
0,
0. 2 times 0 is 0. So that's one term. Next term. First row, second column. 1 times 0, 0. -3 times 1,
-3,
and 2 times 0,
0,
0. First row, what column now?
3rd,
Third. So 1 times 0,
0,
-3 times 0,
0, and 2.
and 2. I want to see at least this step today, okay? Like this. You don't have to do it like we were doing on the other side, but I want to see at least that. Okay, now next row with the columns again, right? So -4 and 1,
-4.
-4, plus 5 times 0,
0.
-6 and 0,
-6.
0. You're multiplying, not adding. What's 0 times -6?
Oh, I thought you said 1.
Hmm.
Where are you at?
I-
Nope, I'm done. I'm done.
Second row,
Why am I
Kyson,
zero?
first column.
Oh.
Now I need to do second row, second column. So -4 times 0,
Yeah, I know.
0. 5 times 1,
5, 0,
Okay.
and I would keep, like, you can touch it. There's no reason you can't keep your finger there. Then I go second row, third column. So -4, 0,
0,
0. 5 times 0,
0,
-6, 1.
-6,
Now I got to do the third row with the first column. So 9 and 1,
9,
plus,
0,
plus,
0,
okay.
0,
Third row, second column.
0,
0.
-7, 0,
Now I want to tell you guys, I don't usually go like this with both. I usually keep my finger on my column. I can keep my row for some reason, my column I lose. That's just me. Okay, so third row, third column.
0,
0.
0, 8. Will you put a plus sign in there?
Oh, yes. So when I do this, I get 1, -4, 9, -3, 5, -7, 2, -6, 8. So did I get what I started with?
Oh, wait, so what's the point in this?
Yeah.
Just to show you that it does. When we solve, eventually we'll work towards solving equations and we'll need that.
Oh, it just shows you that.
Yeah.
It's the same.
It's just, the point of it is to practice the matrix multiplication and just show you that's what it is. Okay, and today your assignment is 5 through 8, correct?
And we got 0.
Okay, 8, you're gonna have to make your own matrix.
It's 3. So.
Don't be throwing things.